Kia ora koutou. Welcome to this session of AMA Online. And it's so great to see so many of you, giving up your Saturday to join us this today. So, as you can see, the title for this workshop is Maths Routines for Building Positive Learner Identities. And we have got amazing Rob who will be taking us through this workshop. Just a few housekeeping. You're most welcome to use the chat feature if you have any questions during this session, and I will find time to make Rob aware of the questions. Please be mute. We all use Zoom time and again, but just try to keep on mute. This session is actually recorded, so if you don't want to be in the video, you can, shut your video down. But this will be then later on shared for us to access it in the future. All right. You will be able to share your feedback with the presenter, and I've got Jared with me who will jump in if I make any mistakes. This is only my second time hosting AMA online. So my name is Ashok Kumar, and I'm one of the AMA exec member. All right, I think we are good, and I would like to now hand over to Rob to introduce and take us through this amazing workshop.
Okay, so thank you, Ashog, and good morena, everybody over there. I'll just get myself organized with technology here. Are people, is that all looking good?
Great, Rob.
Great, okay, so no ingarangi oku te puna and no ingarangi aho ki o te tahi oko kainga I naiene ko Rob Profitt-White aho. So good morning from Otatahi this morning, and it's lovely to be here today to go through some of these rich routines we've been working with the high schools. A quick background to me, I trained to teach in the UK, middle school, primary, intermediate, and then moved to Middle East for 11 years, working in predominantly Asian culture schools. Then we moved to Melbourne, 3 years over in Melbourne, working with the primaries and high schools, then Sunshine Coast for another 11 years. And then we moved over to Otatahi in 2020. And now we're based here, but I work between Australia and Otatahi. So when you get these slides, it's nice as teachers, we know, to just listen to things today, and then you'll have time to go through all the slides, and I'll give you a few contact numbers and ideas as well. So today we're going to be looking generally at some of these routines that high schools for the last 8 years over in Australia and Otatahi have been using to pepper their week to build kids' disposition and competency with some of the processes we know are important in those intermediate high school areas. The new curriculum is not too different from 1997, and it's got your sequence, it's got your concepts, your knows, and it's also got the mathematical processes. This naturally links in to, obviously, we're conscious of the fact in Aotearoa now of the numeracy in year 10, and the numeracy in year 10. Generally, we've got to give kids opportunities regularly to be able to formulate, regular opportunities to explain, to reason, to conjecture, to generalize, all those areas, because we know all those do's, or what's called now the mathematical processes, are absolutely essential in high school. Just so you know, across the border in Australia, what they brought in 2017, I was one of the people working as the advisor to the high schools then about how to boost teachers and kids' morale and ability to do all the numeracy in their year 10. So what Australia did, we got into schools and we got them to start promoting and valuing, formulating, solving, evaluating, communicating. But in 2016, 2017, in the high schools, a lot of the kids weren't interested in that. And as high school teachers or intermediate, you know, sometimes kids can be, oh, why do we have to do this? So we actually made it almost mandatory that all assessment has to promote and value all of these. And in the last 7 or 8 years, it's had a massive impact. So I'm going to share with you some of the routines that the high schools started sprinkling in because most high schools had 3 times 70 minutes. That was the norm. Some had the luxury of 4. One or two even had 5 times 50 for maths in a high school, which is even rarer. But generally, the average was about 3 times 70. So I'm going to start off with a game, a little activity that the high schools are doing, and then I'll show you some photographs. Now, this one is one, again, we call them recall and reason. So Professor Peter Sullivan, who used to be the writer of the old maths curriculum in Australia, he talks about sometimes recalling basic facts is obviously a must in most high schools. We know that. But if you can suck in the reasoning element alongside the recall by getting them to prove, justify, explain, articulate, argue, then these are great ways to practice. And what I'm going to share with you today are some of these things that have evolved over the years. This one is a very simple one that is happening in some of the high schools I'm working with here in Aotearoa. At the start of the week, the teacher gives the kids 3 or 4 single digit numbers. And using mathematical properties, number properties, using rules about number, using some creativity, they have to, by the end of the week, try and prove with equations how many of those target numbers they can get. Now, what I've done for you watching this in the meantime, knowing that you're maths teachers, you're probably trying to figure out how was a 9 and a 2 and a 5 and a 1 used, because you have to use each of those 4 numbers on one side of the equation. So a 9, a 2, a 5 and a 1 in any order equals 25, equals 36. You can use exponents, you can use other conventions in mathematics. So what could be at the start of the week a really good fluency activity, by the end of the week, you can turn it into a investigation by asking kids to work out what they do. And it is a problem because they don't know the answer straight away, but they have usually the fluency or the collaborative Barno community to come together. So in the chat room, if any of you just want to spend 1 minute now, can any of you work out what these high school kids did to get 25, 36, 72, or 100 using those? And I always say to teachers, you ask the kids to ask clarifying questions. I don't over explain initially, because if they do that, they will own the process of these investigative little warm-ups. So if you want to put in the chat room, if any of you can find some. The ones I chose use brackets in some cases, or Gemma, as the new curriculum might now call it in Aotearoa. Okay, thank you. We're getting a few little ones in there. What I'll do, I'll just get you the board that this came from. So here you go. So I was in a school over in just about 3 hours outside of Brisbane, and they are one of the schools who are like peppering their week with these. And the teacher, the physics teacher, actually it was, the physics stroke maths teacher in this high school was saying, Rob, you know, this is happening with our year 11 and 12, which is in New Zealand language, year 12 and 13. So that's a nice little linear expression for you. New Zealand takeaway 1 equals Australia. So what she has on the back of the thing is one example. And she said it was just a lovely way to get, as she said, their dopamine hit each week of just practicing basic skills, because we know now, having worked with high schools now for like 8, 9 years, going into them every day, a lot of the high school teachers are exasperated about just the slow decline in basic arithmetic, basic skills, negative, positive integers. And we're not witch hunting anybody, but it's like, okay, we know it's a problem. We know we're strapped for time. We know that just worksheets and things don't always work. So what can we do just to get a bit more collegiality, a bit of collaboration in? And as these teachers have said, even when we were doing this over at Rangiora, you know, we've got kids will be talking to each other, but keep it 4 or 5 minutes. We know, don't take it long. So these things are just on the back of the room and kids are watching and helping each other. So that's just a quick insight for one such activity. I will give you some links at the end for a number more as well, because it's about, no, it's all about the greater good here. Just while we're on numeracy, a quick insight for you as it's coming over here now for numeracy year 10. One thing as teachers we found when we did a study in all the high schools from Brisbane up to Cairns, questions like this or elements like this were on the numeracy in year 10. And what we found when we looked at all the data from the whole of 180,000 kids in, say, year 9, we found that when kids see these sorts of questions, you can see here, nearly a third won't do it. And I'm sure I'm talking to the converted here as intermediate and high school teachers because they look at it and go, oh God, and there's a series of things we can talk about, but that's for another time. Some of them make careless mistakes. Usually the top kids we found, the upper bandings of the kids will just rush and make the careless mistakes. And what we said to these kids often is, we know numeracy year 10 isn't mathematics year 10. Numeracy year 10 it often comes from 2 or 3 years before. In this case, it was a year 5 question given in year 9 new numeracy test. And when kids realize that, they lack the ability to reason with the question. So one thing these activities I'm going to share with you today also do is they start to chip away at the kids' mental blocks. So when they see something, they don't just go, "Oh goodness, I can't do that." We notice they start to think about things, and we say to them, hidden behind a question like this, if you peel away the veneer of the context, of the representation, of the visualization, there is a math skill lurking behind that you can probably do. So you've got to tell yourself, if you can't do it in 2 seconds, it's called resilience. You need to be thinking. Another one example, feel free to share these with the kids. They find it really interesting. This one was given to year 7 Oz. I've called it year 8. It was a basic question like this. And as you can see, that was the results of 180,000 kids again. A third got it wrong. A third said far too many words, can't be bothered, too hard, what's this? And when we went through it with them, we actually explained to them that even numbers, the kids admitted, these are year 8. Sorry, that was in year 2 or 3. Yeah. What about numbers for 4 digit? Oh, that's about year 3. Yeah. What about adding single digits? Oh, that's year 1. And they're like, oh, I didn't realize it would look so much harder. So that's just a quick insight to some of the stuff that leads to these resources. So before we go into them, we know that the new curriculum here in Aotearoa, we want to make sure that high schools as well as intermediates and primaries are making use of the 4 main types of task: exercise, application, unfamiliar, and open. In Australia at the moment, we know they've actually now got posters to help with that, and I think those will be coming out our way from what I hear over here in Aotearoa. And we know from a high school point of view, we spend a lot of time in that green, or we want to be in that green. And we know the only way some of those things are activated is through types of tasks on the right, unfamiliar and open. But what can we do to start 5 minutes a week to get kids starting to value the skills for the green? And that's where these rich routines started to come in 2015 in the high schools. And the high schools and the intermediate schools and the feeder schools, in fact, that was starting with these routines, it builds their ability to argue, defend, reason, justify. And teachers have said, well, we're getting some traction here with kids who would usually just blank out. They're actually having, as Joe Bowler talks about, assigning competence. They may not be good at number, but they're certainly accelerating in some elements of shape and measure. And when we were doing some of the control schools, with over the years, the reason why it took on and started to trigger across the state, and we were able to write this sort of work up, is because schools were finding after 3 or 4 years trajectory going up. Kids' parents, the parent surveys were getting more positive because in Australia, every school has to have an opinion survey from their year 9s about what they think about the teachers. They have to have one about what the teachers think about the principal, and they have to have one about what the parents think about the school. And that is nationally done in every single school. So once we started seeing schools who are suddenly getting parents being proud of the school and kids enjoying maths more, not just enjoying it, getting better performance, we knew these are worth sharing. So one little thing here, when you're doing games and things as well, problem solving doesn't need to be anything big, because sometimes we know we have to have these big investigations, but at the same time, little things, what we call recall and reason, it's recalling facts and you're reasoning. So turning a game into a sort of a problem. So how can you put the digits 3, 4, 5, and 6 into these boxes to make the answer closer to 100? Okay, in pairs, you've got 2 to 3 minutes to have a go. I'm going to walk around the room as a facilitator. You might have one on the board as a little enabler, but these are just 2 or 3 minute things just to get them thinking. And you might walk past a couple of kids with a good strategy. You might walk past a couple of kids with a misconception, because the reason that graph went up is because these little activities would often be around skills that the teachers weren't planning to teach, but they were prerequisites. And I think we know in this country, like others, by year 9, we've got 40, 50, 60% of kids who are still probably at phase 2 going into phase 3. So we've got to find time to them that balance that whole testing coming up, keeping them on track. So the 4 main RITS routines, they've evolved. They work, and I'm going to take you through some of these now and then give you some links to some. And I'm more than happy for people to write and stuff, because as I said, it's a blessing to be able to work through all these high schools and intermediate schools in different countries and just build and work with teachers on making some little activities just to help. So move and prove, for example, I'll share one with you I just did on Tuesday. I was down at James Hargest Intermediate, and what we were doing there was we were modeling these with the teachers. So this one came in because the year 8 teacher said, look, we just want to have a quick 5-minute move and prove to see what they're doing. So the move and proofs we've made, by the way, when I share the link with you, we spent about 4 years on these, looking at all the common misconceptions that multiple choice type testing companies use. So we collated all the misconceptions, as many as we could find, based on previous tests and all those things over the years, did some research on it, and made a bank of about 150, 200 of these. And I'll give you the link to those. But when you do them, you just want kids in pairs or groups on tables to have 2 or 3 minutes to discuss and defend. It's a lovely way that the high school teachers are using to assess what the kids know for 3 or 4 minutes before they start teaching. So they actually value what our tamariki bring with them, which is part of obviously the curriculum. So that one went up, and we invited a few kids to have a bit of a share. Some kids were saying it was like, I remember this, some kids were saying it was B and C, some kids were saying it was C and D, and there was some collegial arguing, and kids started defending and proving and reasoning. And within that 6 or 7 minutes, as the teachers in the room were watching, it was like, whoa, you can sort of see roughly where kids are. I'm aware that these 4 might need a bit of extension, whereas these 8, I need a bit more time with them. Then we put them into something what we call a revisit and retain. A revisit and retain is, okay, kids, let's just revisit some basics on this from last year, year 7, and remind ourselves. But we want to do it in a bit more of a collegial way. So I said, okay, in my cloud here, there's some expressions from the cloud below that equal 5a plus 9. So can you sort of like gather some terms? But you need to make it, so it's not just 2 or 3 terms. The kids at the front, the teacher allowed them to make them simple, but the ones at the back, they had to use subtraction. We said, you've got to use subtraction. Some kids were asking if they could use division and multiplication as well. So that was the one activity. A backup one was, are they able to write a balanced equation now that has an unknown variable, A, on both sides? And what that did, this week on Wednesday, actually it was, so the year 8s over here were just collaborating. Just for like 10, we set aside 10, 12 minutes because it gave the teachers in the room an opportunity to see, okay, which kids need explicit, which kids need practice and consolidation, and which kids need some open extension to bring in some of those mathematical processes. So some went off after that onto a workbook, fair enough. Some went onto a couple of worksheets, some were with the teacher, and some were independently doing some open-ended discovery tasks that we write. So that's a little process of some of these things. So the recall and reason, these are designed on research. Lisa Darragh from Auckland Uni did a lovely paper on the building games for positive learner identities, and that's where I captured that particular statement there. Also, Peter Sullivan has done some work, and James Russo, on the 5 principles of academic games. We want games to be academic, but we also want them to appeal to kids. So here, when we go into our schools, we go into all the schools and model the reasoning behind it, because we hook in lots of different areas of the maths. I'll just give you one. So what I'll do now is I'm just going to do one live with you. I've got a dice here actually. So what happens here is this. Could I ask all of you, I'm assuming you've got a bit of paper next to the computer. So on that bit of paper, I just want you to draw a double box multiplied by a box and a throwaway box. So that's a total of 4 boxes you will draw. So it's a bit like copying what player 1 is. So just quickly draw a double box. Then you've got as a factor, then you've got a single factor, and then you've got a throwaway box. So this is what a game, and obviously when this game is happening in real life, we make this last 5 minutes because we're modeling the words and actions to make kids think about the probability and likelihood of winning and mathematical outcomes of the dice. But I'll just go through it fast with you today. So what happens is we're going to choose a target number, and we're going to have our target numbers 200. So 200. So we say the person at the end of the game, once they put their digits into those boxes from the dice, that is closest and can prove they're closest to 200 will win that particular round. So what happens then? Don't forget you've got a throwaway box. So I'm just going to have some dice here and just to put some dice in and let's have a go. Okay, a 7. Your first number is a 7. So can you put a 7 into one of those boxes? It could be the tens in the first box. It could be the second one. It could be the last one, or you could throw it away. So a 7. The next one. Oh, 7 again. Okay, another 7. Because each round, if you're playing it, sometimes when the teachers play this initially, it's teacher versus class. So you get a couple of kids up to nominate the class, and the teacher will intercept with good questions like, what would be a good answer here? What would be a good number? What's a reasonable number? What number wouldn't you like? Why'd you put that number there? What's your reasoning behind there? Why didn't you put it here? So you're invoking that mathematical discourse all the time. Okay, the next one. 4. So a 4. So you should have, hopefully, people, 1 box left. You've got 2 7s and a 4. Your last number, oh, 0. Okay. So if you just add up, or sorry, work out what your answer was and put those totals in the chat room. If you put what your final number sentence was, mine was a disaster. Just my 0, there's mine. Sorry, it's a 10-sided dice. Good point. I've just opened the chat room. I was using a 10-sided 0 to 9 dice. I sometimes use 1 to 6 as an intro one. Looks like I'm a loser. I had that 0. In the last one, 47 times 0 was mine. Oh, 280. That's not bad. Okay, 28. So 28, 280. A quick 1-minute activity is like, can they find all the numbers possible with those numbers rolled, and then can they place them on a number line? That's a very good one, because don't forget, number lines will invoke fractional understanding, spatial reasoning, and they also guide mental computation, rounding, estimation. So number lines are key. And that's why once you've done it, I've got an animated slide there for you. Once you've done it there, you get them to do them on a number line. But I would say for high school, because when we're playing this with year 9s and 10s, even though that sheet in front of us says years 1 to 8, we use a 10-sided dice. Another adaptation of this is division. You'll get some moans and groans about this, even when I play this with teachers, because it throws in, it can throw in non-terminating decimals and things like that. So the kids are like, but it's still a good one for reasoning. What we also do with that game, you can see here, is there's so many variations. And when we were doing one of these activities with some kids in the Catholic Cahoyark or here in Otutahi, one of the high schools who was with us, the head of maths there, the head of faculty, she went away with these, and I'm just going to share these with you. And she started making loads of adaptations. So what you see here is just, the blue are the boxes you put the numbers in, and the red is the throwaway box. And she's made another 30 or 40 more, which I think is amazing. I love it when teachers take ideas and run with them. So she's now doing those as 5-minute games from years 9 to year 13, going in and just a quick 5-minute one. And she's brought in like fractions, she's brought in factorials, she's brought in order of operations, she's brought in exponents. So there's lots of variations, and that's just one of the recall and reason games. If we go to revisit and retain, these are just very quick questions. Most teachers will just choose one or two, but it's the process of writing them. Because in high schools, we found that when we did some auditing of all the high schools, nearly every single one, I think it's about 92% of them, would have some sort of quiz or things once or twice a week to varying degrees. Some of them are really engaging. And we said to the teachers, no, great, you're doing these already. Let's just make sure we tweak a few things based on what we found, that kids actually like the same concept over the week, to give them time to practice and consolidate mentally. So things like this are a visit and retain. Okay, kids, no, we're going to do one of these by putting in one pair of brackets. Can you make as many different answers as you can? And can you write each one as an equation? You've got 3 minutes. I'm going to be walking around the room just to see who needs. And if you forget what GEMMA or BODMAS or PEDMAS or whatever you want to call it in 2024, you're aware that you can go and support those. But I also always say to teachers, offer them an enabler, offer them a slightly easier one visibly, because some kids might go onto that one first. And I'd rather them do that one than just sit there and not have anything. And we also encourage you to have a not done yet, because you've got to set your work out. That convinces me that's just one way to extend it. So what schools are doing with these? These are the high schools. This one's in Hervey Bay, which is about 3.5 hours north of Brisbane. The teachers write them, and they write 3 or 4 quick questions, 20 seconds for each one, which gives them time to walk around the room. And then they choose one of them to actually have a bit of a 2 or 3 minute discussion on the strategies chosen, the effectiveness, the efficiency of these things. When we were making them with some of the schools, we just take what are the no's from the curriculum, and we say to teachers, let's just turn the no's into something tangible and visible. So, okay, kids, we're going to this week, a little revisit and retain is going to be looking at representing whole digits and numbers and exponents. So your quick quizzes this week, and they can be very, very simple, like the one you see there. And this is one that some of the schools have been making. This one's from year 8, recognize, write, read, write, represent, compare, order decimals. So these are just these quick quizzes. In fact, these ones are actually used in year 9, because we encourage teachers, like you be aware, to go back a year for revisit and retain, and the clues in the name. You revisit things you should know that you haven't got time to teach, but you just tick them over. So that was a quick insight into revisit and retain. And just an example here, just I thought I'd share this with you. I'm sharing this with one of the webinars with the principals in about a week or two. We decided to do a little project with some kids from primary and intermediate schools, because I'm sure this might resonate with some of you. We know that by the time the kids get to intermediate, a lot of our intermediate schools and high schools sadly are on the back foot all the time, trying to win kids back. And so we're working with a lot of the primaries and feeder schools now to actually build that resilience with the kids and align, that whole transition move from year 5, 6 into intermediate, or 7, 8 into high school. So a number of years ago, we spent some time looking at mental arithmetic, because it's huge. So just recently, by the way, we got over 9,000 Tamariki from Invercargill up to the Bay of Islands. Private schools, public schools, high decile, low decile, rural, city, from year 3 to year 10. And we gave them just 43, subtract 29. which incidentally, by the way, I chose that one because that was given when I was in Australia as the advisor in 2013. It went to 200,000 year fours, and not many got it right. The results here sent in, we gave them the set conditions, and I'll be sharing this, as I said, with the ministry actually. So here we go. So we found that by the end of year 4, at the moment, about 1 in 5 year 4s can solve that. By year 6, end of year 6, it's 2 out of 5. And by year 8, it's about 2 out of 3. But considering this should be mastered by the end of year 4, and considering, as you can imagine, this is the result of just using many programs and Twinkle and worksheets without the conceptual understanding, it's caused a lot of issues. And you can see the result, the errors are coming from both. They're coming from a no understanding of the algorithm. But by year 8, we know that the kids are starting to they're losing their attention spans now for maths. And as Richard Cohen in 2011 said, if a kid arrives in intermediate and they know they can't just do basic addition and subtraction, the whole of maths is switched off. You've lost them before they come in the room. So what we're doing now with these webinars across the country is raising awareness about this, because just so you know, there's a lot of Australia and New Zealand on too many mental strategies when there's only 3. But companies selling 15 strategies, 20 strategies is very lucrative, but it's very confusing. And it sometimes makes high school teachers get a little bit exasperated. So we're trying to clear a line of sight and navigation to actually think there's 3 really main groups of strategies here. Let's just lessen the load on teachers and kids and parents and high schools to boost these things up. So one of the things we're working with high schools now is some mental computation pathways that are needed for any curriculum to work. The move and prove. The move and prove, I just shared that a quickly one with you, but generally here's us with some year 9s. They were doing one before a unit on just rational numbers. And we discovered in groups of 3 or 4 minutes, we gave them a question like this one here, which has some conceptual understanding behind it. And what we noticed with the year 9s, because this school has got the classroom conditions, all these require obviously classroom management and pedagogies to be in place. So the teachers' right attitudes and beliefs are needed for these activities to work well. So when they do have that alignment, these can create some very good mathematical discussions in 4 or 5 minutes, and the teachers are able to go through. And we noticed that the kids started drawing, visualizing straight away. Some were using the double number line from the Netherlands, which was a powerful way. In fact, one kid was invited up to the board to draw his Netherlands double number line, which made the kids go, oh. And I said to them, look, good mathematicians will actually use diagrams, drawings, symbols to communicate, because it's a very good way to show conceptual understanding. So another way that we did it was something like this comes up. And what these move and proofs can do down the track is they're able to be used not just to capture evidence in 3 or 4 minutes, but what some teachers are doing now is they're turning them into an ongoing task to stop the kids saying they're done after 5 minutes. So obviously there's a lot of, when we work with schools, we go through how to write these and do these, but you don't know, you're able to do this quite independently. So these were year 8s on Gold Coast. So that's our year 9. So they have a move and prove each week, and then they have like 3 or 4 minutes on this lesson, 3 or 4 minutes on the next one. And what they had to do was they had to just create their own by the end of the week, because writing your own right and wrong is like explicit instruction, having examples and non-examples. Another similar one was something like this. This was the move and prove given to year 9s. So we said, right, after we saw so many kids making mistakes, we said, in your group, your explicit routine for the week, because we're going to be doing area and perimeter this week. So your ongoing task as an exit pass in pairs is you're going to draw and label your 2 separate rectangles. You need to make sure you calculate the area. You need to make sure you join the 2 together. And you need to work together to put in the missing numbers to make it look more complicated. So it goes back to what that typical NAPLAN, PAT, EASTL type multiple choice one does. And we want you to start off by making one correct and one incorrect, because it's just a nice way to start. And what you found is some year nines who were at a year 4 level were able to have a go, basic ones, but they were still having a go. Some kids started to go up a bit, they started to write ones where they could put in, their ideas. But some kids in year 9 were able to go zooming off, because the whole idea of a low floor, high ceiling, it's the same task, but to capture kids in year 9 at a year 4 level and at a year 10 or beyond level started going. And as a teacher, they were in control. So these were these ongoing tasks that activate investigation, conjectures, reasoning, generalizing, all those things start to appear. The fourth one is just discuss and defend. Now, discuss and defend is about 5-minute snapshots. We know from Peter Lillijar's work on building thinking classrooms in a high school perspective, having 5 or 10 minutes on a non-curricular task each week is very, very powerful for the kids in a student-centered classroom. And when I say it's non-curricular, it doesn't mean it's just a free-for-all. It might be going back to something, but just because you're teaching Pythagoras for 3 weeks because it's on the test, there's also other prerequisites around Pythagoras that also need to be refreshed and revisited. And discuss and defends are that one. I've given you here, even though these, as the high school teachers found, initially, sometimes on here, they do link up into high school. I was with the head of faculty at Southport on the Gold Coast, and she went to year 13 with these. And she said, Rob, even though sometimes they look like, they could be like year 5, 6, my year 13s were getting into it and having some good debates. She said it was really interesting. So that slideshow, when you see it, we've given all our schools now links to all the free stuff, because the free stuff is hard to find. I'm suspicious about why it's so hard to find. It's almost as if people want you to buy it. But we make sure teachers get access to the free stuff. That's enough to give you ideas. And things like, these are some examples, what's the same, what's different? Okay, kids, what's the same, what's different? And in classrooms where the teacher values and believes in discussion, explanation, justification, reasoning, we find we go in and within 5 minutes, you've got kids debating, drawing, coming up on the board, really good kids having a go and proving. So what's the same, what's different is one such site. Always, sometimes, never. Always, sometimes, never are great ones that we do, but it's making sure the teachers have the right questioning and the prompts to dive deep into those areas. So those ones are, again, some good ones to get debates. So summing up, one area that is underused, and it's one thing that the high schools I'm working with now have gone, oh, wow, there's a few useful things here, is on the ARBs. Now, the ARBs, as we know, go through into the old level 4 and 5. And there's quite a few things. So I've got permission to give you all the generic password and username to get right into these. And inside, when I was with the high schools of the day, we spent about half an hour just going into them, giving the teachers time to go, oh, wow, I found something. So we set them up in little groups to find things from the different strands, like probability, stats, geometry. And they went in to get some really interesting ideas, because basically, the new programs, these magical silver bullet programs that are being written, aren't going to be anything different. They might change the fonts, they might change the name, of course, and they might change the price. But generally, they all come from free resources. So getting your head stuck into things like ARBs or NZ Maths, they're going to be the same as any paid book, if not better, because there's more time to actually go into the details. So the ARBs are a really good free place to go to. And when you go into them, as one high school we work with said, Rob, we've been into these, and we found some good things, and we made a whole suite of our own move and proves purely from going into these and snatching them out. I said, absolutely great. What a really clever idea. So we've got a Facebook page. We've got a number of teachers on here now, about 10,500, I think. It's predominantly a lot of primary intermediate, but there are a number of high school teachers on here who just browse through and pinch things and take things, which is what we want. And on it, TLF Maths Ideas and Insights, there's things we're going to be posting up some more ministry stuff at the moment as well, and some webinar links around, what explicit teaching looks like in various domains. But the idea is, even though I've got links for Australian schools at the top, I've just realised that I need to change that. The links there are for everybody, by the way. But the last page here, you see these links here. This one will take you straight to the routines. That middle link will take you straight to the free move and proofs. And the bottom link will take you to some really good resources for digital. Now, these are ones, especially in that 7, 8, 9, 10 area, where if you've got classes that need some visual stuff, these are free. And there's some powerful stuff I've seen being used even in senior school, where teachers are just reminding kids about some graphical ways of looking at algebra, simultaneous equations, and things like that. So that's quarter two. So I'm going to stop here and just go through and see what things have been hopping into the chat room. If I can go into the chat room now.
Not really any questions posed on
That's
the.
okay. I
Yeah.
mean, if people want to write in now, I mean, there's we've got two minutes if anybody wants to ask anything.
Yep, there is a
Oh,
question there.
Jay Rickman, 3 mental strategies. Okay, to paraphrase this, because it takes a while, there's your place value sort. Place value tends to be either splitting both numbers or jumping from one. And you can do it with the inverse. So if subtraction becomes addition, that's a place value one. So if they're just breaking the numbers into tens and ones, both of them or either, that's more place value. Then you have styles ones we call compensating. Compensating is where the person looks at the numbers and has the ability and the nuance to manipulate the numbers. They might, in a multiplication, use factorizing. They might round and adjust. So for something like 43 take 29, they might go 43 take 30 and then adjust it. So they have the power to manipulate. And then, of course, the last one is basically the column algorithm, which works fine. It shouldn't be demonized, but it needs to have the right understanding. And what's quite horrifying in Australia and Aotearoa is, despite all these books being used 3 or 4 hours a week, you still have 1 in 3 after 400 hours of instruction by year 8 unable to do 43 take 29. And you think, what's going on? There's hours spent on it, but it's the idea is we've got to make sure teachers know how to teach the concept behind place value that's aligned to that, and that's one of those things. Okay. NatPlan have shut down big time now. There's an email went out to all the schools in Australia to say any old testing and things have to be withdrawn. I think it's because all these companies around the world, they're running out of good questions. Let's face it, there's not an infinite amount. So I think all the countries like the PAT and the ASTEL and the SATs in the UK and the NatPlan, they don't want all these questions in handbooks around, because there's going to be a state that need to go back and start using some old ones. So there's not much out there I can share on that. I've got quite a lot of stuff when I go into the schools, but I'll just write my email address in the chat room now, because when we're traveling around the country, because we've got about 280 schools now we're working with just in Aotearoa, and it's about, sometimes if I'm in the area and schools are nearby, calling in is fine. It's about, as I said, it's all about sharing the greater good. I'll put that in there. So I've just put my email in the thing now.
Thank you, Rob.
That's okay.
Are you gonna come back in, or shall I do it?
Oh, yeah, I just wanted to say, Rob, thank you for sharing this work. And I can see, I just want to talk all of the comments that's coming up. For maths teachers to give up their Saturday and come in and be involved with so many resources, which is research, backed and evidence based. This is fantastic. So thank you so much for sharing those.